All right, so we're going to talk about how we name acids according to our fancy IUPAC rules. All right, first thing, when we are naming acids, we need to look at the anion, and really we can think about acids as being more bound covalently instead of being bound like ionically. That's really what's going on, but it can be helpful to think about what the name of that latter part of the acid would be if it was an ionic compound. So here's an example. Let's look at HCl. Now, if we just had Cl by itself, what would Cl be called in this case? Chloride, right? We'd name it chloride. It would have that "ide" ending. Anytime you have, without the H, whatever's left, anytime whatever's left would have an "ide" ending, the convention is to name it hydro blah 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 ic acid. So in this case, HCl becomes hydrochloric acid. By the same token, that example that we had just earlier, H2S, what would S be just by itself? Sulfide. It has an "ide" ending, so it follows the hydro something something ic acid rule. So it becomes hydrosulfuric acid. Okay. What about HF? Somebody raise your hand and tell me, what would HF be? Where was that? Yes. Hydrofluoric acid, very good. Which is super, super corrosive. Okay, great. So we've got this pattern down. Hydro, and then whatever the name of your anion, we can think about it that way, even though it's not really what's going on. Whatever that name is plus acid. Okay, that's our naming convention. Now, something else to note about naming acids for the exam. I will try to be specific, and sometimes I mess up on this, but I will try to be specific and tell you when I'm asking you to write these names, if you have these compounds in a gaseous form or in aqueous form, because the name can change depending on whether something's a gas or something's aqueous. Now we're going to run into this in chapter 4. If we have hydrogen sulfide, or if we have H2S gas, it would be dihydrogen sulfide or hydrogen sulfide. But if this is in water, put aqueous there on all these. If it's in water, then that hydrogen can dissociate and it becomes an acid. Okay? So it really depends on the state. And on the exam and going forward, I'll try to be very specific about whether these are aqueous or whether they're in gas form. Okay? For this exam, mostly you can assume if you see H plus something else, it's going to be an acid. Okay? So that's the first convention. Something ide becomes hydro blah 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 ic acid. Are there any questions about this? Yes?
This might be really stupid.
No such thing.
I might be overthinking it. Like, it's sulfide originally, but you add the when you change it to like hydrosulfuric.
Mm-hmm.
Like, when do you know to add the rest of the word?
I think that a lot of that is just kind of the speech pattern. Like hydrosulfic acid just sounds kind of weird to me. If it comes down to like a spelling error like that on the exam, I'll be pretty lenient. And it's just something that you'll gain with experience is where you drop things off. So that's something else to note, is that on the exam, as long as I can tell what you're trying to say, then I'm pretty generous as far as like spelling errors. Obviously, a spelling error between nitrate and nitrite would not be acceptable, but any other kind of spelling error I'll try to be generous on. Okay, so this convention is if you have "ide" for the ending. Let's talk about if you have "ate" for the ending. Now our classic example of this is H2SO4. If we just consider this part, so not counting the hydrogens, if we just look at this latter part of the molecule, what would be the name of this guy? Sulfate. All right, sulfate. If you have an 8 ending, that 8 goes to ic, becomes ic acid. So you can think about I ate something and it made me sick. 8 to ic. So in this case, H2SO4 would be sulfuric acid. Now, going to the comment before we had where H2S was mistakenly identified as sulfuric acid, that is an incredibly common mistake. It's so common, in fact, that it might show up on the exam. I'm not saying, I'm just saying. Sulfuric acid is H2SO4, and there's an easy way. I told you my mnemonic, right? Johnny was a chemist's son, but Johnny is no more. What Johnny thought was H2O was H2SO4, right? Kind of morbid, but it'll help you remember the formula. Yes?
So when you do these, are you going to go from the name to the formula, or the formula to the name like we're doing here?
Either one. I think that doing this way is difficult, kind of just more so than going from this to this, but you should be able to do both ways. I might ask you both ways. Let's do another example here. So we've got HNO3. So what is NO3 here? Nitrate. So what's the name of this acid? It's nitric acid. Good. All right. How about this? What's the name of this one? Ooh. Chlorate. So what's the name of the acid? Chloric acid. All right, let's do another one. Cl4. What's the name of that? Perchlorate. So what's the name of perchlorate? So what's the name of this acid? Perchloric acid. Good. Great. All right, so that's 8 to ic. Again, we're looking at the endings. If we didn't have any hydrogen, what would the ending be for that anion that would result? If we have 8, we go to ic. All right, next one. Let's do this, H2SO3 now. Let's consider this case, H2SO3. SO3, if we just had that there, SO3 2 minus, right, we'd have to have the charge with it. What was the name of this ion? Sulfite. Oh, great. And again, that's not one that you have to memorize. If you've memorized sulfate, you should be able to recognize sulfite. Awesome. Now the way that this works, this naming convention, is if something takes an ite ending, it's whatever, us, acid. And the way to remember this is I got the itis, okay? I ate something and I got sick, it gave me the itis, is the way I like to remember it, okay? Sounds silly, but you will thank me. So this would become sulfurous acid. All right, what about this guy? What's the name of that acid? Someone raise your hand and tell me. Yes. Yeah. For this one here. This one? Ooh. What is the name of this one? This is nitrite. Good. Okay. So what's the name of the acid? Yes. Good. Nitrous acid. I think that's actually my fault, not yours, because I'm. No. It's too much loud music. Hard for me to hear. Okay. Nitrous acid. All right. What about this guy? What's the name of this guy? Chlorite. So this whole thing becomes what? Chlorous acid. Okay. What's the name of that guy? Hypochlorite. That's hypochlorite. So what kind of acid is this? Hypochlorous acid. Hypochlorous acid. Okay, good. All right, so this is basically the pattern that we follow. We get rid of the hydrogens and say, what would the name of this be if we didn't have hydrogens around? And then look at the ending of that name, and from there you can go from the ending to how we would name the acid.